So now let's turn to page 64 and take a look at structure question 20. The question here asks about the metal axe here, right? So it lists 3 different reactions. One is heated with oxygen, another one is cold water, and the third one should be diluted hydrochloric acid. Let's look at the first one. It says it's not burning, but there is a black coating that is formed, right? So let's record our memories from tutorial 2. I've written a table for you guys to list the color of the metal itself and also the color of the metal oxide. So let's list it again. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, SN is tin. So if you forgot about that. Lead, hydrogen, copper, mercury, silver, platinum, and gold. The color for metal itself, from potassium to tin, they're all silvery white. And then for lead, it should be shiny gray. And then hydrogen does not have any color, right? Copper will be reddish brown. Let me use another color then, reddish brown. And also for mercury, it will be dark gray. Silver and platinum, they're all silvery white. And gold is a golden in color. Let me use a yellow color to represent gold. Alright. Now, what about the color? Like this one is the color of metal itself. What about the color of its oxide? So here, from potassium to aluminum, the color are all white. It's pretty easy. And then for zinc, it has like 2 different colors, right? When it is hot, it will appear to be yellow. And when it is cold, it will be white. That is the one for zinc. And then for iron, like its oxide was black. And also tin is also white. Alright, about lead, it has 2 different colors. So it will be, if that is hot, then it will be orange. If that is cold, this color should be yellow. Then let's put a PB next to it to avoid any confusion. So hydrogen, surely we cannot observe any color, right? And for reddish brown, the copper oxide, the color is black. And then for the mercury, the color should be red. Mercury oxide. And then for silver, platinum, and gold, as they're very stable, it won't combust in air to form our oxide, right? So this, you can take a screenshot. This will be the whole color table for our metals that we have already learned. And then let's go back to this question again. So here it says it reacts heated with oxygen and it will have a black coatings on it. Let's see from here. Which oxide, heated with oxygen, it will surely will form oxide, right? So which oxide here is black? We only have iron and also copper, right? So let's see. This one should be iron or copper. So iron or copper is firstly determined from here. And then in no reaction with water, either copper or iron, they won't have reaction with cold water, right? But let's take a look at diluted hydrochloric acid. Remember, every time in between Fe and copper, I ask you to write hydrogen in between, right? So remember, the elements that in front of or before the hydrogen, they will be able to react. But if that is the metals that's after the hydrogen, they won't be able to react. So here, no reaction happens, which means the answer should be copper, right? So here we write A as a copper here. Okay, then let's take a look at question B. State 2 observations that could be made during a reaction between sodium and water. So these, please take a look at your textbook. It should have 3 points, right? One should be melted in a silvery ball. I still put melted here. So firstly, melts into silvery balls. And then second, freezes quickly on water surface. This one is the second point. The third point here would be burns. If the hydrogen gas catches fire, it will burn with a golden yellow flame, right? Golden yellow flame. And we highlight this one in yellow. Alright, so this will be the reactions for B1. This will be the answer for B1. And then let's write the B2 here. So it asks us to do, right here. So it asks us to write the chemical equation for the reaction involved. That reaction between sodium and water, right? Remember the word equation, if we want to react sodium with water, it will form sodium hydroxide, right? Hydroxide, and also probably it's better for us to use plus here. So hydroxide and then plus hydrogen. So now, can we write the balanced chemical equation? So sodium is Na, water should be H2O, and then goes to sodium hydroxide, right? This one should be NaOH, and then hydrogen will be H2. Now let's try to balance the equation here. How about, let's start with, let me think about it, probably on hydrogen. So we have, how many hydrogen here? We have one H2, so it'll be 2 hydrogens, right? So here we only have 1, and here we have 1 H2, also 2 hydrogen. This one is 2, this one is 1, but left side we only have 2, right? What can we do to make it trying to balance? It will be better for us to put a 2 in front of it, then this one will be 4H. I know this one have 2H, so if we put a 2 in front of it, all together it will have 2H plus 2H. The right side will have 4H, right? And then let's continue. Check the oxygen, whether it's correct. We have rainbow method, 2 oxygen on the right, rainbow method, 2 oxygen on the left, and then let's take a look at the sodium. How many sodiums on the right? We have 2 sodiums here, right? And also, these only have 1 sodium, so we have to put a 2 in front of it. Is it balanced now? Alright, then what is the last step for us to do the chemical equations? Think about it. It should be the either gaseous, liquid, or aqueous, a solid state, right? So sodium is a solid. Water surely here will be cold water, so it's liquid. And sodium hydroxide, this one should be aqueous, and then the gas will be hydrogen. Alright, so this will be the answer for B2. Now let's take a look at C. For C1, it asks you to write the observations of magnesium and diluted hydrochloric acid, right? So if we dissolve them, if we put the metals into the acid, surely the first one we should be able to observe the gas bubbles are gives off, right? This will be the first one. Gas bubbles are given off. Remember, also the magnesium will be dissolved in the acid, right? So these are the 2 observations. especially this one. Don't forget about it if you're asked to write the observations. Okay, now let's move on to the second balance equation part. They ask you to write the chemical equation for reaction between magnesium and diluted hydrochloric acid. So here, magnesium react with hydrochloric acid. Which one should it form? It will form magnesium chloride, right? So what's the charge for magnesium? It will be 2+. And the charge for chloride is minus. So let's do the cross method here. We should have magnesium chloride, right? And also, gas that gives off, the gas here should be hydrogen. Now let's see whether it's balanced. How many chloride on the left? We have like 1 CO2, so it's 2 chloride atoms. On the left, we only have 1, right? So it's better for us to put a 2 in front of it. Now let's check. How many hydrogens on the left? We have 2 hydrogen. How many hydrogens on the right? We also have 2 hydrogens, right? And also check back magnesium. It is also only 1 on the left and only 1 on the right. So the last step for us is to add the state, right? Similarly, solid, aqueous. Remember for HCl is aqueous as it can dissolve in water. This one's also aqueous and gas.